Hello everyone, welcome to this video. In this video series, we are solving previous year's questions from integral equations. The second question we are taking is from June 2018, consisting of 4.75 marks, right? Let us see the question. The question is, consider the integral equation, this, phi of x is given to be lambda integration 0 to pi cos x cos t minus 2 sin x sin t phi t dt plus cos 7x where x lies between 0 to pi, then which of the following statements is true? That is, do we have for every value of lambda, do we have a solution? That is, a solution exists. They are saying for every value of lambda such that the solution does not exist, there is no solution for every value of lambda. For every value of lambda, they are asking, is there more than one but finitely many solutions? Or for every value of lambda, there are infinitely many solutions. So let us see the form of integral equation which is given to us. It is a Fredholm kind integral equation because of the limits these are constants. Moreover, it is a Fredholm equation of second kind, right? Because of this term. Moreover, we have fx non-zero, so it is non-homogeneous, right? So let us see how to solve this equation. Moreover, you can observe here that this kernel is separable or degenerate kind, right? So how can we solve such kind of equations? Let us see. So this is our integral equation, given integral equation. So here we can separate these terms out, right? So here this integral is only dependent on the term t, right? So we can take this cos x common. So we have cos 7x as it is plus lambda as it is, then cos x is taken out, integration from 0 to pi, cos t phi t dt as it is, minus from here minus 2 sin x. These are constants, that means they are not depending on t, so we can take these out from the integral sign, so we have this whole term, right? So now this integral term, this one, I can call it as c1, and this term I can call this as c2, right? So these are my c1 and c2. So the solution finally becomes phi of x, ultimately here phi is unknown, right? So we need to calculate phi. So phi is equal to cos 7x plus lambda times cos x c1 minus 2 lambda sin x c2. Now the c1 and c2, they both contain phi. So in order to calculate this phi of x, we must calculate what is the value of c and what is the c1 and what is the value of c2, right? If we have the values of c1 and c2 with us, we can put these values in equation number 1 and we can obtain this unknown phi, right? So for doing that, let us first start with c1. In doing that, we need phi of t. So from equation 1, you can see that we have phi of x in terms of others. So we can replace the variable x with the t. So we'll have this equation phi of t is equal to, in place of cos 7x, we'll have cos 7t plus lambda times cos x c1. We have plus lambda times cos t c1. And in place of this minus 2 lambda sin x c2, we have minus 2 lambda sin t c2. That means we simply replace this x with t. Now putting these values of phi t into this equation c1, what do we have? We have this integral 0 to pi as it is, cos t as it is, and this is the value of phi of t. So now we have to solve this integral in order to obtain the value of c1, right? So this would reduce to an algebraic equation. Let us see how in few moments. So let us separate these terms. So this is integration from 0 to pi cos t cos 7t plus then lambda times this becomes cos square t and this becomes cos t sin t. So here how to solve this one? Here we have dt and yeah. How to solve this equation? So basically you multiply and divide by half, so you will have this formula 2 cos A cos B. What is the formula for that? It is equal to cos A plus B plus cos A minus B. So we just have used this formula. So we have cos 8t and cos 6t over here. And here, what is the integration of cos square t? For that, again we'll go to double angles. The formula we have used is cos square t is equal to 1 plus cos 2t divided by 2, right? So we use this formula, and in place now here the angles this t and t, they are same, so we can divide or we can use this 2, so it will be sine 2t, because you know sine 2t, that is equal to 2 sine t cos t, right? So these formulas we have utilized. So we obtain these terms. Now we can easily integrate them. The integration of cos 8t would be sine 8t by 8 and cos 6t by sine 6t by 6. We can evaluate the limits. We know sine 8 pi and sine 6 pi is 0. Again, sine 0 is 0, so we have 0 over here. Moreover, let's see the second term. Here we have constant, so it would be t, right? This 2 I have taken out common. Then t, and integration of cos 2t, it would be sine 2t divided by 2. The limits from 0 to pi, so it would be pi, then sine 2 pi would be 0, then t 0, and then sine 0 would be 0. So ultimately we'll have lambda c1 upon 2 into pi, right? Let's look at the third term. We have this thing. So what is the integration of sine? The integration is minus cos 2t by 2. So this minus and minus is absorbed over here. So we are left with this. And when you put the limits into this, you'll have cos 2 pi minus cos 0. So that would be 1 minus 1. So that would be 0. So ultimately we are left only with this term, right? So this term is written over here. So we have C1 is equal to this, or we can write this as this. So let's label this as equation number 4. This is one equation. Let us now calculate the second equation using this formula of C2. We'll use this formula. Here we will put the value of phi of t. Let us see what we obtain. So C2 would be integration from 0 to pi sine t phi t dt. So it is equal to, we have just used the value of phi t as we have discussed before. Then we have separated the terms, right? Then here we have used the formula of 2 sine a cos b. So that would be equal to sine a plus b plus sine a minus b, right? So this terms becomes this, and here we have used the formula of sine 2t as discussed before, and here the formula for sine square t in terms of cos double angle. What is that? It is equal to this, right? So after writing the formulas and simplifying the terms, now we can integrate. So the integration of sine 8t would be minus cos 8t by 8, and here this sine of minus x is equal to minus sine x, right? So you see, in order to solve an integral equation, you must have the formula of trigonometry at your tips, right? So yeah, so integration of sine of minus 60 would be 1 minus would be out, and then 1 minus would be from integration of sine 60, so it becomes plus cos 60 upon 6. Limits from 0 to pi, let us put the limits. It would be cos 8 pi and it would be cos 0, so 1 minus 1 would be 0, and here also cos 6 pi minus cos 0, so it would be 0. This term would be 0. Moreover, let us integrate this. It would be minus cos 2t upon 2. The limits are from 0 to pi. When we substitute the limits, again we have cos 2 pi minus cos 0, so that would be 1 minus 1 plus 1, so it would be 0. And the third term would be the constants as it is. Then we have integration of 1, that would be t, and the integration of cos 2t would be minus sine 2t upon 2. So let us substitute the limits over here. So we have pi as it is, then the sine 2 pi would be 0, then t0 is 0, and then sine 0 would be 0. So ultimately this is the only term that we are left with. So we have c2 is equal to this, or this becomes our equation number 5, right? So we have these two equations 4 and 5 as one equation is this, another equation is this. So we can write this in terms, these are algebraic equations, right? So we can write these in matrix form. So we have a matrix of this form. This is the coefficient matrix. This is these are the unknowns which we have to calculate, and these are the right hand side which are 0 in this case, right? So here we do not know what is lambda. So depending on the value of lambda, the behavior of these solutions changes, right? So first of all, what we do is we see the behavior of this lambda. So what we do is we call the determinant of this as d lambda, right? So let us calculate d lambda. What would be that? It would be this term multiplied by this term minus 0, right? So this thing is equal to 0 whenever this thing is 0, and this when this thing is 0, we have two options. Either the first term is 0 or the second term is 0. The first term is equal to 0 gives us lambda is equal to 2 upon pi. The second terms give us lambda is equal to minus 1 upon pi, right? So these are the two cases. So let us consider them one by one. So when our lambda is equal to 2 pi, the system above becomes, let us see at the system. When lambda is equal to 2 pi, this term is 0. So we have 0, 0, 0, and here we have lambda is equal to 2 upon pi, pi cancels, we have 3. So this becomes 0, 0, 0, 3, C1, C2 and 0, 0. So from here when you solve this, you get C2 is equal to 0, and you do not have any condition of C1. So that means C1 is arbitrary. So in this case, what is our solution? The solution is given by which of the equations? The solution is given by this equation. Phi of x is equal to cos 7x plus lambda cos x C1 minus 2 lambda sin x C2, right? So let us substitute the values of C1, C2 and lambda into this equation to see what do we obtain. We obtain, because C2 is 0, we have this equation, and moreover the value of lambda is equal to this. So our solution becomes this, right? Where C1 is some arbitrary constant. So that means we have multiple solutions in this case. Why? Because as we change the value of C1, the solution phi x changes, right? So let us see the second case. In second case, we have lambda is equal to minus 1 upon pi. So the system star, this system over here, what does this becomes? We have lambda is equal to minus 1 upon pi. So this becomes plus pi cancels. So 1 plus 1 by 2, that would be 3 by 2. This term would be 0, this term would be 0, and this term would be 0, right? So we have 3 by 2, 0, 0, 0, C1, C2 is equal to 0, 0. From here you get C1 is equal to 0, and C2, again we have no condition on C2, so we can say C2 is arbitrary. So in this case, what is the solution? The solution, here the term containing C1 is 0, so the solution using the earlier equation number 1, we have phi x is equal to cos 7x minus 2 lambda C2 sin of x, right? And what is lambda in this case? Lambda is equal to minus 1 upon pi. So this becomes the solution in this case. Again, it depends on the C2, where C2 is arbitrary. Therefore, in this case also we have multiple solutions to our equation. So let us look at our options. We are clear that the equation results in infinitely many solutions. So option D is the right option, right? Moreover, if you see the options carefully, you'll observe that option B says that there is no solution, so this is wrong. Option C says that there are more than one but finitely many solutions. This is also wrong, because we have infinite number of solutions, there are no finite number of solutions. So option A is, look at the option A. For every value of lambda belongs to real numbers, a solution exists. So this is true, because here they are not talking about the unique solution, but they are saying for every value of lambda, one solution exists. Yeah, this is true. They are not saying one solution, but they are saying there is a solution for every value of lambda. So this option is also correct. So the correct options are A and D. That is all for this video. Thanks for watching.